are gathered here to gain knowledge about environmental science and from our chief guest, Mr. R. Chandran, Deputy Director of National Productivity Council. Here comes Ms. Sweta to deliver the welcome address.
Good morning, everybody. Firstly, I extend a warm welcome to our chief guest and faculty members and all my friends present here. Our chief guest, Mr. Chandran, Deputy Director of National Productivity Council, Dr. Ambedkar Institute of Productivity. And here I have few things to say about his career. He did his BTech Chemical Technology in the year 2000 in CCRI Institute and ME Environmental Management in 2008 in an Anna Institute and worked for 5 years as a process engineer in manufacturing department, as a consultant for 8 years in environmental field, 5 years in Delhi head office. Presently, he is working in Chennai for the past 3 years. I hope you all would enjoy the session. Thank you.
Thank you, Shweta. Now our chief guest will take over the session.
So today's topic given to me is environmental pollution. So I will be covering the overall pollution, starting with air pollution. Different types of pollution will be covering it actually. So the causes, effects, and the control. Hearing a lot of pollution thing actually. So can you define the pollution? So what is your understanding about the pollution? Pardon? Contaminated material. Unwanted material. Toxic material.
Mixed with our surrounding and it causes the environmental pollution.
The material which is causes the environmental pollution.
The unwanted material which is mixed with our surrounding and the environment, we have a limitation.
Okay, unwanted material is mixed with the surrounding, which causes the undesirable effect. So almost you are nearer to that actually. So anything actually, just if you want to put in concrete term actually, already our environment has some basic concentration. So whichever component which is altering our basic concentration and adversing the, which is causing the impact to the health or to the material, then that is called as a pollution actually. So here we can define it actually. Changing background concentration. So already in the, suppose if you take the air or the atmosphere, so some concentration already that carbon dioxide will be there and oxygen will be there and some other material components or concentration in terms of, suppose oxygen is there, NOx is there, some little bit concentration will be there. Suppose some pollutants or we can call it some gaseous which is coming to the atmosphere and it is changing the concentration of the background concentration. Already that concentration is there, so it is changing the background concentration. So once it changes the background concentration, any substances introduced into the environment that adversely affect the usefulness of the resource. And because of the change in background concentration, it will affect, which will interact with the material or it will interact with the human, so it will be inhaled and it will cause the adverse effect. So that is the basic definition of pollution. So it can be applicable to the air, it can be applicable to the water, it can be applicable to the soil. So depending upon the change in the background concentration, it is called as different pollutions. So why it's happening actually? Because the industrial process is there. So for development of the country, industry should be there. And industry need energy for various equipment to run another thing. So once the energy is needed, it should be taken from fossil fuels and other thing. So once the fossil fuels, what is fossil fuels? Any idea? That oil, coal and all these things are called as fossil fuels. So fossil fuels, once they are through the power plant or other thing, you will be getting the power through the fossil fuels. Once the fossil fuels is burnt, we will be emitting different gases like SOx. When it is sulfurous content is present in the coal, when it is burned, combustion process, sulfur dioxide will be evolved, NOx will be evolved. So this will be coming finally to the atmosphere and it will be altering the concentration of the atmosphere. So which leads to the pollution, air pollution. That is called as air pollution. Suppose if it is coming to the water, changing the concentration of water. So that will be a water pollution. So basically the change in the concentration of the basic level. So the undesirable thing which will affect our human health, and it may be a human, it may be a plant, it may be a material, anything actually, it will be affecting it actually. That's why it's given that pollution happens because no process is 100% efficient. So we are not converting entire thing into the product. Some waste will be coming out actually. So that leads to the pollution actually. So different pollution, air pollution is there, water pollution is there, soil pollution, noise pollution, marine pollution, thermal pollutions. Different pollutions is listed here. So once it enters the air, water, soil, what is noise pollution? So noise pollution, you will be knowing all this air, okay, once it enters this thing. So calm atmosphere will be there. Suppose noise is given. So what is the desirable limit actually? That any idea? So noise is measured in terms of what actually? Unit of noise measurement. Decibels, yeah. So what is the desirable limit? Some standards will be there for this thing. So once above the standards, what is the limit? Any idea? 75 decibels or 125 decibels, 90 decibels. Depends upon the area actually, whether it is an industrial area, whether it is a sensitive area like hospitals and other things. But depending upon the area, the limit varies actually. For sensitive area like hospitals and other things, it will be less compared to the industrial area. So night time it will be different, daytime it will be different. So all these things will be derived based on the study actually. So in India, we have different agencies for monitoring of this environmental pollutions, and regulatory agency is there. Their ministry is there actually. So in the central level, Ministry of Environmental Forest is looking after all this standard formation and thing. And the technical wing of Ministry of Environmental Forest is Central Pollution Control Board. Hope you are aware that CPCB, Central Pollution Control Board actually. So that is the in central level. So technical wing for MOF, it is a part of Ministry of Environmental and Forest, which is formulating the standards. So for this area, these industries, load-based standards is there, concentration-based standards are there, different types of standards are there actually. They will be formulating it, and they are giving to the, it will be gazetted in the notifications. Once it is gazetted in the notification, that will be applicable to the industry. So that standard formulation is from the central level. So in India we have different states. So implementing agency should be there at the state level. Central cannot implement all over the state. So in the state level, State Pollution Control Board, depend upon the state. If it is in Tamil Nadu Pollution Control Board will be there. If it is in Andhra, it's Andhra Pollution Control Board will be there. And in union territories, it is not called as a Pollution Control Board. It is called as a Pollution Control Committee. That is a name they have given in union territories like Pondicherry and other thing. It will be called as a Pollution Control Committee actually. Not instead of board, there will be a committee actually. So these are the agencies in the state level which will be implementing the standards formulated by the Central Pollution Control Board actually. So that's how the different, depending upon the sector-wise standards will be there. Common standards also will be there. For all industries, some common standards will be there. Every industry is different. Every industry's raw material is different. So according to the raw material, the concentration or the pollutants coming from the industries also will be different. Some pollutants will be common and some pollutants will be specific to the industries. So the standards also specific to the should be specific to the industry. So that's why we have that the sector-specific standards for different industries apart from the common standards. So normally these common standards also will be there and sector-specific standards also will be there. That is about the standards and our in India the setup, how that is implemented. So here will be air pollution, water pollution, soil pollution, different pollutions are there actually. So we will be seeing, majorly we will be focusing on air pollution, water pollution, and this water pollution control systems will be there. So water will be going there and will be effluent treatment will be there. There is different process in the effluent treatment, primary treatment, secondary treatment, tertiary treatment will be there. So we will be treating the water, wastewater, and finally water cannot be converted it can be this thing. It can be converted from one form to another. So solid will be removing it from the water. That solids, how it will be disposed. So different solid waste management will be seeing it actually. So whether it is air or whether it is water, solids will be there, which is undesirable solids. We'll be removing it from the different control systems, and the solids which we are called as hazardous solids, some may be hazardous solids and some may be municipal solids actually. So that type of solids, how that we have the system to manage it actually. What the rules is saying to manage all these solids, we will be seeing actually. So this is the overall, this is air pollution. With regard to air pollution, composition of atmospheric air, classification, source of air pollutants, effects of air pollution on human, plant, material. So this is with respect to the air pollution, this is the thing, overall thing we will be seeing it actually. Different control methods to mitigate the air pollution. So air pollution, as I said before, one or more contaminants or combination in such a quantity and in such a duration, injurious to human, animals, plant life or property. So which is causing impact to the adverse impact to the human life or animals or plant life, then it is called as, that pollutant is called as air pollutant. So before you understand the air pollution, we should have some knowledge of our atmosphere. So in the Earth's surface, that first layer is called as troposphere. So above that stratosphere, mesosphere. Yeah, this thing, different layers are there. No, that is atmospheric pressure actually. So this troposphere is the layer which is near to our Earth actually. Here different altitudes in kilometers and temperatures it is given actually. So pollutants, some pollutants in the troposphere may not be a pollutants in the stratosphere. For example, ozone. Ozone is a pollutant in troposphere, but it's not. It's very much needed in the stratosphere. Otherwise, that ozone layer, ozone hole you heard actually. Ozone hole, ozone depletion. So which will cause the adverse effect. Yeah. So we will be seeing what is ozone depletion or which the gases which are affecting the ozone layer depletion, and all these things we will be seeing it. So pollutants are classified into two types in air pollutions: primary pollutants and secondary pollutants. So any idea about primary pollutants? Can you give some examples of primary pollutants? What is the primary pollutants and secondary pollutants? Example, any example of primary, secondary pollutants? Yeah, sulfur dioxide. Sulfur dioxide is an example of primary pollutants. Secondary pollutants? Yeah. So, primary pollutants, these primary pollutants will lead to the secondary pollutants. Combination of primary pollutants, one or two pollutants will lead to the secondary pollutants. Some examples we will be seeing that primary pollutants are SOx, NOx, sulfur dioxide, nitrous oxide are all primary pollutants. And these are also particulate matter, sulfur dioxide, nitrous oxide, volatile organic compounds, VOCs, generally called it as VOCs. Carbon monoxide, lead and some other more pollutants are there. Some of the few examples. And this secondary pollutants, this smog and all these things are secondary pollutants actually. So this is the source for the primary pollutants. So main combustion process, due to combustion process or from chemical process, nuclear process. So these are the different processes, chemical processes, how the primary pollutants are emitted. So this is a man-made, the top is called man, from the man-made activities, the pollutants are coming in actually. And some naturally also some pollutants are coming, that also is listed here. So these are some secondary pollutants. like sulfuric acid. For example, sulfur dioxide is coming and it will be reacting with moisture and it will be giving sulfuric acid. So that is one of the secondary pollutants. Smog is a secondary pollutant. Photochemical smog. This is some due to ultraviolet radiations. Not even from primary pollutants, it may react with UV radiation also, and it will lead to the secondary pollutant. Smog and photochemical reaction. This is photochemical reaction. This smog, photochemical smog and other smog will be done. And one example is ozone, which is formed by VOCs. VOCs from the VOCs through use of ultraviolet radiation, this ozone will be formed. This ozone is a very strong oxidizing agent, so this is one of the secondary pollutants. These are some of the examples. So primary pollutants, secondary pollutants, and different examples. So here, for better understanding, this picture is given actually. So from the mobile source, stationary source is there, mobile source is there, and vehicle is the mobile source. Stationary source is the stack, which is found in the industries, generally called as chimney. In industrial term, it is called as stack. So that is a stationary source, and this is a mobile source. So here sulfur dioxide and nitrous oxide is coming, and it's reacting with water moisture, and it's leading to nitric acid, orthophosphoric acid, or hydrogen peroxide, fans, and other things. So what is the problem of this issues with the air pollution? Pollutions are there, some impact will be there. So what is the impact? Different impacts, any idea? So any various impacts of air pollution? Yeah, acid rain is one of the impact. Yeah, ozone layer is one of the impact. Global warming. Global warming, how it is caused actually? Which gas is a major contributor to global warming? CO2. CO2 is a major contributor. CFC is chlorofluorocarbon. Yeah, CFC is that also one of the thing actually. That also greenhouse gas actually. Even some other gases, any idea? SF6 is there actually. That also cause to global warming. These are some of the major gases. You will see that what is acid rain? Acidic nature of rainwater. So for pure rainwater, what is the pH? 7. Yeah? 7. Any idea? Pure water, pure rainwater, not pure water. The water you collect in the air surface by the rain. If the pollution is not much actually, not polluted, atmosphere is not polluted, normal concentration. So what will be the pH range, pH of water? Any idea? 7? 7 you are saying, yeah? It will not, below 7. How much? Below 7? 6. Why you can below 7? Acid mix. So if it is not pollution, if it is not polluted, if atmosphere is not polluted, you are saying acidic rain. You are saying, na? It is not polluted. Then? So that's alteration in basic concentration is pollution. So without alteration in basic concentration, what is the pH? 7. You will see. What is the pH now? Rainwater? Clean rainwater? 5.6. So why it is 5.6? Why it is not 7? Acidic content comes from?
Greenhouse gases.
No, actually in this thing is troposphere, already the carbon dioxide is present in atmosphere. So carbon dioxide will react with water and it will form the carbonic acid. So because of this formation of carbonic acid, that rainwater is, clean rainwater is 5.6. So if pollution is there, then what other acids will be formed? What other acids will be formed? Solution is there. Nitric acid, sulfuric acid. So these are all the acids will be formed. So because of that, so pH varies actually. So now what is your understanding of acid rain? So pH will reduce further. So acid rains will be 4.2 to 4.4. So if you measure the pH of rainwater, acid rainwater, if it is in 4.2 and 4.4, then it is called as acid rain. So these are the different pH range. Sea water, how much it is pH, then ammonia, then from basic to acidic. So lemon juice is around 2, orange juice 3. So these are for your understanding. And what is the environmental impact on acidic nature? So all these dyes are around 4.2. So once this acid rains goes to the lake and everything and it will make acidic, then these are the effects created by the acid rain. So this is some more effects. So once acid rain is coming and it's pouring on tree, direct damage to the leaves and bark, reduced photosynthesis rate will be there. Once the photosynthesis rate is reduced, automatically that will be death of the plant. So suppose if it is coming to the contact with the soil, then the soil acidification will be there. So it will be reaching to the lake and destroying the fish and the eggs and other. So other thing, that nutrients in the soils also will be reduced. Bleaching, because of bleaching of acidic nature, essential nutrients will be discharged to the lake and it will not get into the tree. Because of that also tree will die and other thing. So these are all some of the impacts of negative impacts of acid rain. So this is ozone layer depletion. So as I said before, ozone is a pollutant in troposphere and it's very much needed in the stratosphere. So how that ozone depletion is there? So natural phenomena, some ozone concentration will be a natural destruction of ozone particles. O3, that is called as the chemical formula of ozone. There will be a natural destruction and formation will be there. So less than 240 nanometers ultraviolet wavelength, if it is heat, then automatically that will be formed, ozone will be formed. And if it is greater than 290 nanometers, ozone destruction will be there. So once this ultraviolet radiation with more than 290 nanometers, then ozone destruction will be there. And when it is less than 240 nanometer, ozone formation will be there. So by this natural phenomena, ozone will be destroying and forming. So one balance will be maintained. So as far as the balance is maintained, there is no issue actually. Ozone layer will be a thick layer and it will prevent the ultraviolet radiation it will prevent the ultraviolet radiation. So how this will be affected actually? So once, what is the ozone depleting substances? Any existing? CFCs, chlorofluorocarbon is one of the this thing. SFCs, that also this thing, one of the thing. Halogens, that mostly this halogens, chlorine, fluorine, bromine, all this thing actually will not the entire compound, only this atom, chlorine atom or bromine atom or this thing. That is the more, chlorine is more prone to ozone. So we will see how. So how that process is going on. So chlorofluoride, CFC is coming out from the different source and it's slowly from the troposphere to it's reaching to the troposphere, stratosphere. Troposphere to stratosphere it's reaching. So once it reaches ultraviolet radiation, it will hit and the chlorine atom will be removed. So this chlorine atom will hit the ozone and the chlorine oxide will be formed and oxygen will be formed. So once this is ClO plus O, where this O is coming, by the natural process the O will be coming from this thing. By destruction O will be there and this O will react with the chlorine and chlorine atom is once again will be formed. So this chlorine atom once again hit the ozone and this process continues. So that is how that this chlorine atom will destroy the ozone. So this is a natural process. There is no problem. Destruction and formation will be there. So there will be a equilibrium. So because of this chlorine atom, it will be hitting only the chlorine atom which is hitting the ozone, and it will destroy the ozone layer, and not at one time. Still the chlorine atom is present, it will keep on destroying the ozone. So this chlorine atom, there is some lifetime in the atmosphere. So till that time it will be destroying it actually. We will be seeing what will be the lifetime of all this. So this is the effects of ozone layer depletion on human and animal health, terrestrial plants, aquatic systems. These are some of the effects. Air quality, mineral. So in national level and international level, there is a different mitigation measures. One of the measures is Montreal Protocol. So international bodies they come together and they will discuss how to mitigate these pollutions and everything. That one of the protocols they come out is the Montreal Protocol to phase out the ozone depleting chemicals like CFCs. It started long back 1974 by tax imposing and all these things they are giving it, and they are replacing with the different substances actually. Most of the substances now at present chlorine is not there, mostly used in the air conditions. Now it's chlorine free refrigerants are we are using, but other halogens we are still using it actually. We are yet to find some replacement for other halogens. So that is the status. So global warming and greenhouse effect. As you said that carbon dioxide is one of the greenhouse gas. So what is greenhouse effect? What is greenhouse effect? Increase in atmospheric temperature, modifying the temperature. So greenhouse effect is needed or not? Not needed. Needed. Greenhouse effect is needed or not? Needed. Not needed. So here we have given natural greenhouse effect and enhanced greenhouse effect. So now greenhouse effect is needed or not? Or natural greenhouse effect is needed or enhanced greenhouse effect is needed? Natural greenhouse effect is needed. So what is actually that in as you said the carbon dioxide, methane are all the greenhouse gases which is allowing the heat radiation to pass, but it will not allow the heat radiation to pass away from the layer. So this is a thick layer. This is a layer formed by the greenhouse gas. So heat radiation is coming in and it is rejecting the heat. Some amount of humidity will be observed and it will be some amount will be rejected actually. So as long this effect is there, there is no problem. So suppose because of the human activity and everything, this layer is increased. See, that red color portion is small, here it's increased actually. Because of increase in nature, only this less heat escapes into the space. Heat is trapped inside in that greenhouse gas. That is an enhanced greenhouse effect actually. Because of the more heat trapped in that layer, that our Earth's surface is heating day by day. So natural greenhouse effect is very much needed, but enhanced effect is not needed. Without natural greenhouse effect, our Earth's surface temperature what it will be? It will be around minus 18 degrees centigrade. If it is greenhouse effect is not there, natural greenhouse effect is not there, our Earth's surface temperature will be minus 18 degrees centigrade. It will not be that any human life will not be there. So greenhouse effect is very much needed, but enhanced greenhouse effect is not needed. So that is enhanced greenhouse effect and natural greenhouse effect. Hope you understand this thing, na? Greenhouse effect and enhanced greenhouse effect. So this is some of the greenhouse gases: carbon dioxide, nitrous oxide, ozone. CFCs, methane. So carbon dioxide is the major source for this greenhouse gas actually. It is coming from burning of fossil fuels. Fuels which contains one carbon which react on combustion with oxygen and leads to CO2 and heat energy. Heat energy is used for power generation or steam generation, all these things. And the CO2 which is coming out through the chimney is let out into the atmosphere. And this CO2 which is coming to the atmosphere, trapping more heat and causing the Earth's surface to increase the temperature day by day. So that's the thing actually. Different source, and CO2 is a major source, and other gases also contributing for greenhouse gas. So since some statistical data, 2010 actually, how much CO2 is coming in million tons in different source, and where it is sink is 91% from fossil fuel burning. Chimney is coming out, and land use also burning this thing. Some amount of CO2 is producing, and in atmosphere it's 50% the sink, and tree carbon dioxide will consume and oxygen it release. There are also some percentage it will observe sink, and in ocean also because of diffusion and I think it will CO2 will be going sinks and source. So other technology is carbon sequestration. So they have come out with the carbon dioxide major source is there actually, and from the different stacks, and I think the carbon dioxide can be trapped and it can be put into the sea where the depletion is there. So that is one of the things called as carbon sequestration. And one of the global greenhouse gas emission, the year 2013, it's around 36 gigatons of carbon dioxide is emitted actually through this combustion process. So this is the global warming potential and greenhouse gases and lifetime actually. As I said, that CFC, once it's gone to the atmosphere, it will stay up to 100 years. So lifetime, once it reaches there, it will stay in 100 years, and slowly after that it will come out from the stratosphere. So similarly for carbon dioxide, once it will be 200 years. So if PFCs, perfluoromethane or perfluorocarbon, around 50,000 years it will be there actually. And this is with respect to carbon dioxide global warming potentials. So with respect to carbon dioxide is given actually. So the methane, nitrous oxide. So which are the more global warming potential here? SF6, yeah, 22,000 the global warming potential. But because the quantity is very less, it's not much contribution to this thing. Carbon dioxide is the major contributor actually. So that's why that CFCs is not that much focused, because it's not coming out from the process in huge amount. So these are some of the global warming effects. Increase in ocean temperature. So ice melts, as surface temperature increase, you will be hearing about actually all these things. Loss of biodiversity, diseases, then food shortage, direct and indirect impacts.